All right, everyone. We're at exactly 12:45. So we'll move on to the Columbia DevOps spot. And today we've got a renowned developer advocate, Tiffany, here to. So everyone likes to talk about containers, likes to talk about a lot of automation and everything. Um, and really, you can kind of get left behind. So what Tiffany's going to hit us with today is a little bit of an intro to Kate's and to see how we can be effective with that. And I'm just going to stop taking up her time. Tiffany, take it away.
Okay, cool. Thanks. And renowned, that's pretty funny. Maybe one day. All right, cool. Let me share my screen and hope everything works correctly. Okay, so can you see my PowerPoint slides and nothing but my PowerPoint slides?
Yes.
Awesome. Okay, cool. So as I was introduced, I'm Tiffany Jernigan. I am a developer advocate at VMware, and I'm mostly just focused on Kubernetes, though other people on my team are also focused on things like Spring. Today I'm going to be talking about getting started with Kubernetes. So some of this stuff, depending on what level of experience you have with Kubernetes, some of these things might be completely new to you, or you might already know all of this and be like, wait, why am I listening to this? I already know this. I'll tell someone else to watch it or something. But thank you for coming and listening to this morning, afternoon, or depending on wherever you are. All right, so let's get started. So I'm going to take a quick step back before actually talking about Kubernetes itself. So in 2013, Docker came along and basically they changed the container space. Containers had been around for a long time, but that's when this huge influx of using containers started to happen. People started taking their giant monolithic applications and then that were just single thing, running it. If there was an issue that you would have to make a change and it would involve your entire code to be rebuilt, and therefore it would take hours or days or whatever it is to be able to actually run your applications with their new changes. So people started taking these giant applications and then breaking them down into smaller components. So things like if I have a database, having that be separate from my front end, and then having these components end up being run in containers. Generally, the container image, basically, it encapsulates everything that you need to run your application. It has the operating system you need, and it should have everything else in there that is needed for that specific part of your application. And it's stored in stored in a small lightweight image. Basically, there are things out there that you can read for, say, multi-stage builds, etc., to help make your container images smaller. That way it takes less time to pull down and less time to end up running it. So these containers, one of the great things about them is that they can be run on any machine in a repeatable way. So there's none of that, well, it works on my computer, and it not working on someone else's. So basically with this packaging and the ease of being able to distribute it, such as through any of the container registry like Docker Hub or some of the Harbor or some of the other ones out there, basically you can easily just go and get your containers and then scale them up or down based on whatever requirements that you have. So cool, we have containers. Well, containers, they make it easy to be able to build, manage, scale your applications. And basically people were having maybe like starting off with a couple containers to learn how to use it. And then they ended up having more and more. So people might be running, say, hundreds or thousands of containers. Managing that by yourself is extremely tedious. It's complex. Maybe you'll have tons of scripts or just start trying to build your own framework to be able to do this. So basically, people needed help for this. So that's where Kubernetes came along. Kubernetes was designed to fill this gap for orchestrating your containers and your container workloads. So dealing with your containers, the container things like that you can set up for dealing with container versions, dealing with having all of your nodes and being able to find those, checking to see if certain things are up or down. Kubernetes helps do all those things for you so that you can spend more time worrying about your applications. So at its core, Kubernetes is an open source container management platform. So you can just go over to GitHub, pull down the code, you can mess around with it locally, and you can make contributions and push it up so that the rest of the world can benefit from the things that you have done to make the improvements that you've done with it. So basically, it's built to help you run your containers at scale, and it comes with a bunch of different features and functions to be able to build a proper distributed application using the 12-factor app pattern. So if you haven't heard of it, the 12-factor app is a methodology for building software as a service apps. So you can just go look up 12-factor app pattern or 12-factor apps at any point. So also the Kubernetes API, it can basically be thought of as just like a single extensible API that can be used to abstract your resources both within public cloud or on premises. So in a quote by Kelsey Hightower, he says that Kubernetes is a platform for building platforms. So basically you can use it to build, he mentioned some other places that you can use it for building a platform that's such as like a Heroku or a Cloud Foundry clone, for instance. I probably should have swapped the order of these slides since I mentioned it already, but basically one of the big things about Kubernetes is that it can run anywhere. So you can run it on premises. You could run it, I could run it on my machine or on a server in some office. And then people just getting started now, they can choose, okay, do I want to run my applications on premises or do I want to run it in the cloud? So many customers like Kubernetes like for that reason. Basically, you can either start in the cloud or perhaps you have a bunch of legacy applications running on your own servers and you then want to eventually move to the cloud. So if you could stay, but if you decide that you want to move to the cloud, then you can move those applications into containers and start building those new applications in a cloud native way. And then running all that stuff on Kubernetes on premises. And then once you just have that working, there's only, depending on what provider or what you end up using, the lift to be able to move from running locally to on premises is pretty small. And there's tons of guides out there for how to do that. And another option is to run hybrid. So you could have some of your workloads running on premises, or you could have, and also have some things running on the cloud, or you could have things all on the cloud across different providers. There's just a huge array of options. All right, so now that we've just kind of gone over the high level stuff, let's go into the some of the Kubernetes concepts. Okay, so first thing that I want to get into is cluster components. So basically, there's the concept of a cluster. Everything that you do in Kubernetes is within this cluster. And within a cluster, there are nodes. So you can think of these nodes can be either virtual machines or they can be actual physical machines. So that just kind of ties back to what I was mentioning before about on premises or in the cloud. So there's there are two types of nodes. There's control plane, which I'll be going into several in more detail for these things in the next couple slides. But there's a control plane and master, and then there's also worker nodes. Okay, so looking at this diagram, there's maybe a lot. It's not as scary as some of the images I've seen on the internet, but they're mostly just scary, thinking that there's a million things that you have to figure out. So basically, clusters are split up between the control plane and the workers. So each of these can consist of multiple nodes. So I can have multiple nodes that are in my control plane. I could have multiple worker nodes. So let's take a look at some of how this kind of works. Let's like dive into this stuff a little bit more. Okay, so for the control plane, so basically there's the concept of a Kubernetes master, and that master is basically responsible for maintaining the desired state of your cluster. It's a collection of like 3 processes that need to be running, and these can run on a single node in your cluster, which is designated as the master node. So these things are the Kube API server, or on the screen, just API server, the controller manager, and the scheduler. The cloud controller manager is there if you are doing something with a cloud provider. Okay, so basically the API server, which I mentioned a little bit earlier, it is like the main point of your cluster, or it's the front end of your control plane. It basically exposes the Kubernetes API. And as you can kind of see in this image, everything else talks to the API server. And if we actually take a look back here real quick, you can see that kubelet and kubeproxy also talk to the API server. Okay, so cool. So next, let's talk about etcd. So etcd is a highly available key value store, and it basically is there to store your cluster data. You need to have an odd number of etcd, like instances of etcd running, because you need to make sure that you have quorum. There's also the scheduler, and this watches for newly created pods that don't have a node assigned yet. It basically goes and selects a node to run on. Okay, so next we have the controller manager. So at a very high level, the controller manager runs controllers. Some of these controllers are the node controller, which deals with nodes. There's the replication controller, which will make a little bit more sense when I talk about things a little further down the road. And then, as I already mentioned, the cloud controller manager it's optional, and it's used for cloud providers. Okay, so now let's look at worker nodes. So worker nodes as well, you can have I don't know if there's a certain limit, but you can have a bunch of worker nodes for running your applications. So within each worker node, you have these 3 things. You always need to have these 3 things. So there's kubelet, and kubelet is there to make sure, it's an agent that basically goes and makes sure that the containers in your pod are running and healthy, which is obviously super important. Then there is kubeproxy, and kubeproxy is what enables you to talk to other services in the cluster via a cluster.local address. Basically, it maintains network rules, which allow network communication to pods from network sessions in and out of the cluster. So without kubeproxy, you would not be able to be on the outside and try reaching anything in your cluster. So then there's also the container runtime. Even if you've never heard of Kubernetes, but you've been involved in the whole Docker container space, you probably have heard that. So for the most popular container runtime, at least right now, is Docker, and the container runtime basically is just responsible for running your containers. And these worker nodes are also, so like it's responsible for running containers. So basically the worker nodes are also where you end up having your pods, which I will talk about next. Okay, so let's get into objects. So Kubernetes objects basically are persistent entities in the Kubernetes system, and Kubernetes uses these entities to represent the state of your cluster. Okay, so first there's the pods. So pods, basically, they're the smallest and simplest unit in the Kubernetes object model that you can either create or deploy. They can be used to run like you can run a single container, or you can have run multiple containers that need to end up working together. So this is kind of dorky, but you can think of containers kind of as whales because, well, Docker and the Docker whale. And pods in general are like a grouping of whales. So you can kind of think of it that way, as a pod being a grouping of these containers. But again, dorky. So when a pod is run standalone, if it finishes for any reason, it will not be started again. So that's where some of these other objects come in handy. So one of the ways to be able to run a pod that will actually restart on failure is to use a deployment. Deployments basically are given the number of pod replicas, or like basically if I have a single pod, then I'm running a container of Nginx, and it's determining, do I want just one of that pod running, or do I want multiple of it running, and how many of those replicas I want. So each deployment, it will go and it will watch a replica set. And this replica set is what's ensuring that the right number of pods is always running. And so previously, some of the ways of dealing with this was using the replication controller, but now the recommended way is to use a deployment with a replica set. Okay, so some other things are, there's stateful sets. And so stateful sets, they manage pods that are based on an identical container spec, like a deployment. But unlike a deployment, stateful set, it has a sticky identity for each of the pods. So in other words, though they're all created from the same specification, they're not interchangeable. So say there is a pod that you want to run on every single one of your worker nodes. You want to ensure that, hey, if I have 5 nodes, I want to have my application running on all 5 of those nodes. You could try doing a deployment with 5 and hoping that it schedules it in a way that does that. But if one of your nodes goes down and you get a new node, it'll end up scheduling it onto one of the other existing ones, most likely. So that's where a daemon set ends up coming in. Basically, it just does that. It runs a single replica or copy of your application or of your pod on every single node. So I'll show you a bit later, but this is used for things like DNS, etc. So then there's also jobs. So jobs, they basically run your pod or multiple pods to completion, whatever that is defined as. Then there is another level of jobs. So there's cron jobs, and these are basically useful for creating periodic and recurring tasks. So I can have a job that goes and runs something, like it could say hello world every minute, or just something that is running on a certain schedule. And there's a bunch of different things you could do to change like how you want that, like when a certain hours you want that to run from, or a certain amount, like periods of time between each one. So basically they can be used also to schedule individual tasks for a specific time. Okay, so now let's take a look into services. And a lot of this stuff that I'm going into will make a lot more sense when I actually go into the demo, which will cover at least some parts of this. Okay, so services. So basically, services are used to access your application outside of the pod itself. So it's only, depending on how your application is set up, it's only if you have, say, a web server and you want people to be able to access your web page. Only being able to access that from within your pod is not very helpful. So basically these services, they end up giving a stable endpoint to connect to a pod or a group of pods. There are several different types. There's the cluster IP, there's node port, load balancer, and external name. So, and then there's a bunch of other types of services as well. There's headless, etc. But I'm not going to get into that today. So let's start first by looking into the ones I just mentioned. Okay, So cluster IP is the default service type. So if you don't do anything with your setup, that is what ends up happening. So since it ends up giving you an IP address, and this IP address that you're allocated is private, so you basically end up you're only able to reach it from within your cluster. So either if you are SSH'd into one of your worker nodes, or if you are running interactively with a pod that is on the cluster. So next, so that's useful if you just want it to be inter cluster communication. So another one is node port. So unlike cluster IP, this one can actually be reached outside of the cluster. So what happens is you are given a port, and that's in a specific range, and then you are able to use the external IP of any of your nodes on that specific port and be able to reach your application. Though you may, depending on how, say if you're using a cloud provider, you might have to change some security settings for what ports are open. Next, there is a load balancer. So basically with this, it's an external load balancer that is allocated for your service. So this typically is some sort of cloud load balancer, such as like on AWS, there's ELB, and on GCE, there's GLB, and there's Azure has theirs, etc. So the thing about this though is that since it's using an extra service, it'll cost a little bit of money in some sort of like range of cents for the usage, but it's still an additional added thing. So, all right, cool. Let's now talk a little bit or look a little bit into networking, not really talk about, because I guess I'm the only one blabbing here. So, all right, networking. Okay, so a little high level on the Kubernetes network model. So basically the short version is that everything in Kubernetes is just one big giant flat network. There's one big subnet with everything in it. There's the nodes, the pods, everything. So you can kind of think of like a big castle with their like huge tall walls, and then there's like the moat around it. So if you're inside of the castle, you can talk to everyone there and communicate. And in this case, it's the pods and the nodes being able to communicate. But if you're outside, the only way that you can get in is through special ways, such as like if there's a drawbridge, or in the case of Kubernetes, that is by using a node port or like a load balancer, these types of services. So in detail, these nodes, basically, they need to be able to ping each other directly. The pods are able to ping each other directly, and then the nodes and pods can ping each other without using nets. And the networking stack, it basically decides what IP address is given to a pod. And these things here are the specific rules that Kubernetes mandates, but other than that, there isn't any other mandated particular implementation. So next we have the container network interface. It's basically it's a library that has basically defines ways for Kubelet to be able to interact with network plugins. It has a pretty well-defined specification. If you can see the link well enough to maybe screenshot it, or I can share it afterward or something. It has the definition for what that network configuration is. So CNI plugins, they're basically just binary programs that take care of IP allocation and setting up the networking containers. So when Kubelet goes and creates a pod, it calls to one or a sequence of multiple CNI plugins that will end up doing their job one after another. So it's kind of like an assembly line. So typically our CNI configuration will leverage one or multiple CNI plugins to do things such as allocating an IP address. And this is done by calling an IPAM plugin There's adding a network interface into the pod's network namespace, and then there's configuring the interface as well as required routes and anything else. And again, I'm just going pretty high level over this. There's so much more stuff, and I added some links that'll be at the end here, but there's a lot of stuff, and this is just kind of intro, like taking a quick glance at it, which especially is the case for this next part on security. Security is very, very important, but there is so much to talk about with it. So I have just put a very high level of it and added a link to where you can learn a lot more about it. So some things that can help with security, there's a concept of namespaces, and you can use these namespaces for like a separation of concerns. So for instance, which I'll be showing a little bit later, you can have a namespace for Kubernetes has its own namespace, kube system, and that's where all the Kubernetes system things end up being, all the Kubernetes system objects end up being run. And the default is what is the default one that you end up running your applications in, but you can make other ones, and therefore you can set up different rules where certain things in one namespace can't see others, etc. So then there's service accounts, and then there's RBAC, which is role-based access control. So basically, this is used for fine-grained access, defining like what can be done and by whom on what resources. So you could give some service account or someone only specific permissions to say view everything that's on your cluster, for instance. So, or you can have something like between like dev, prod, etc., like where you want to make sure that someone only has the access that they need and can't accidentally do something to the rest of your cluster. So there's and then there's also secrets that are used too. So there's a lot. Take a look at the link there, and like dive into that, and I will continue on to the next stuff. And then if later after everything there are more questions on stuff, I can see what I can try answering. Okay, so separately from security, I just didn't have an in-between slide here. So basically, the next part is just like talking about how. So when you talk about like the main point of interacting with a Kubernetes cluster is using the API server. So one of the ways of being able to do that is using the CLI tool, and people either call it like kubectl, kubectl, etc. And I don't know if there's actually a right way of saying it, and I kind of go between multiple. So basically, yeah, it's just used for interfacing with Kubernetes. There's other ways, of course, such as if, say, you're programming an application in Go, you can use the Go client for Kubernetes. But if you're just getting started and you're just trying to figure out how all this stuff works, just using kubectl or kubectl is the easiest way to go about that. So then there's also this file, it's called the kubeconfig file. It's always located in this place. Well, by default, they suggest that you put it in .kube/config. You can change the file name, and you can change where it's located if you set the kubeconfig environment variable to that location. So with that, I am going to take some water, and then I will start my demo. One sec while I move all of the Zoom faces or lack thereof out of the way. Okay. Is the font size large enough?
Can you type a few words for us? Looks good from where I'm sitting.
Cool. All right. So I guess before I jump straight in that, if you are wanting to just like look at Kubernetes in general, if you just go to kubernetes.io, it has basically is just a ton of resources, documentation. It is the main website for Kubernetes. So I'm not going to go specifically onto anything here, but there's different things like training. You can just go like learning the Kubernetes basics, and like some of the other specific links that I added earlier for RBAC. Those are all on this website. Okay, so I just mentioned kubectl. So I already installed it. There's a bunch of different ways to just go and do that. On Google, you can just search like installing kubectl. You can do it like Helm, and if you're using Mac, and then there's other ways for Linux and whatnot. So first thing that I need to do is I need to make sure that I actually have kubectl installed. So the first thing to do, you can do one of the easiest ways. I mean, you could just do kubectl, or you could do like I'm going to do a kubectl version, and then that should tell them, okay, cool. So I have it, and then you can see that I'm using GKE for this demo. I have used AWS. You can use kubeadm or Kinds and Minikube, etc., running locally. But just for the purposes of this demo, since Zoom and running your own Kubernetes cluster locally don't really get along, that or my laptop will just start trying to fly and probably blow up instead. All right, so cool. Now we have that. So I mentioned that there were nodes. So in GKE, you and several of the other cloud providers like AWS, I don't know about Azure because I've never used it. It's on my to-do. But basically, they make it so that you can see, so the control plane is managed by them, and you are just responsible for the worker nodes. This can either be like pretty much fully unmanaged worker nodes, or there are different like managed ways of dealing with your worker nodes that are out there as well. And so I went before this and went into GKE and created a cluster with my worker nodes. So I believe I created with 3. So to just look at something like that, to make one of the things that you have to do after making sure you have kubectl is to ensure that you have your worker nodes and that they are running. So the next thing I can do is I can do a kubectl get nodes. And then you can see there's the 3 with, it has GKE, I made my cluster name just my initials because I'm currently using a coworker's GKE account. And then you can see the Kubernetes version. And so like, if you're just thinking about just regular Kubernetes versions, then there's like the 114, and then the part that's added at the end is like whether GKE, and this is also the same for like EKS, is like whether they make certain patches for, say, bugs that maybe have been found and have not made it to mainline, or things that they have to specifically do with just to make things work that are eventually, most of the things end up going to mainline. Okay, so then if I mentioned that there is a kubeconfig file, so I'm just going to show where that is. I'm not going to actually show it because it has data that gets redacted that I don't want to share with the entire world. So if we do, so that's in a kube/config. So we can see that I just have one in there. But to see the majority of what's in there, you can use kubectl, and you can do kubectl config get context, or I mean I can't type and think at the same time. Kube config view, and then so basically, if it looks just like a chunk of stuff right now because it's a little complicated because I have I've added multiple different clusters to this kube config. So you can see here that there's multiple clusters, but there are a few things that it ends up needing. So there's a certificate authority data that's, at least for these ones, is provided by the service. Like, so it's either for Docker desktop, it's provided by Docker. The EKS one is provided by AWS EKS, and then I have two GKE clusters that are both, well, I guess one doesn't exist anymore, but basically, and it has the server to be able to actually connect to it. So basically, this file is everything that is needed to be able to communicate and connect to your cluster. And then, so you can see that there are contexts, and you set your context to the cluster that you want to be interfacing with. So the one that I have right now is this. So it's GKE, then it's the project name, which is my coworkers, the region. So for this one, it is in the Dalles in Oregon, and then my cluster name. And then there's other things like users there, and then so with EKS, it uses an IAM authenticator for like the bridge between IAM and RBAC. And then there's all these, basically there's all these other ones for like GKE and for Docker desktop, which I have a Kubernetes cluster. Okay, so now that I've mumbled my stuff up, so the next thing is I want to actually like just take a look at these contexts. So if I do kubectl config get context, then if I do that, sorry, with the screen width, it's kind of hard to see some of this. But basically, that giant chunk of stuff that we saw in the config view, you can see here that has all of the ones here. For some reason, Docker ends up having two clusters, though, or it has two contexts for the same cluster. No, I didn't exactly figure out why, but yeah. So, and then you can see the one that I have for AWS, and then the two that I have for GKE. And then you can see on the side there's that little star. So another thing that you can do if you don't want to see, say if you have like a giant thing, and you just want to know what am I using. So you can just do kubectl config current context, and that will tell you what your current one is. So you can see that star matches up, and it's just the one that I'm currently on. Okay, so another thing that we can look into, since I mentioned it, is namespaces. So there, like some of these commands have like short ways and long ways of being able to type them out. So like you could do namespace is like typing out namespace. I think you might be able to do namespaces. There's NS. To see a whole thing for all this, you can do kubectl and then help. And then basically this just kind of shows all the different things that you could be doing. And it even actually breaks it. The cool thing is it kind of breaks it down into like what, if you're new to this, like what do I need to be able to use? So to be able to create resources, there's run, which you can do to just like, it's kind of like Docker run. And you can just do that if you want to just quickly run a specific image on your cluster. And then there's, yeah, it just has some of the other options as well. So if we go back down here. Okay, so let's take a look to see what the namespaces that we have are. So if we do kubectl get ns, because I'm lazy. All right, so then we can see here that we have 4 different namespaces. The ones that I'm just going to mention for now, which are the ones that you have to pay the most attention to, are default and kubesystem. As I mentioned, kubesystem is where it has basically everything that the Kubernetes system is running, and it keeps that stuff separate from everything that you are running. It makes it like some of the separation also in general makes it harder for you to accidentally delete something running in another namespace that you don't want to mess with. So default is the, well, default space. It's where your pods and all your other resources just are run if you don't go and create yourself a new namespace. So if I want to just see like what pods are running in kube system, I can go and do kubectl get pods and then -n kube system. So -n is for namespace, or I think you can do -- namespace to type it all out. So depending on like where you are running this, the things that are run in here could be different. No matter what, you will have your like kube or kube core DNS. And then you have kube proxy. Metric server is either run by default or like with AWS, it's something that you run afterward. And then you can see that some of these other things are specific to what GKE decided to run. So Google's Stackdriver, Prometheus, which is open source tool for metrics, and then FluentD as well. And so just kind of like getting an idea, if you look at that, if you you can see how many of each were trying to be run, or how many of each pod was trying to be run, and then how many are currently. And you can see how many times it's tried restarting, which means that all these started up successfully. And then 35 hours is just how long that I've had this cluster up and running. Okay, so then if you are trying to say, if you want to create a deployment. So if we take a look again, like we can, you may not be sure of like what the types of things that you need. So you can just do kubectl create deployment, and then you can give it help. And then if we look here, you can kind of see an example. So it's just like here, create deployment, give it whatever the name is, and then you give it what your image is. So this is just like if you're running your container, like what image do I want to have? And this is assuming, so this deployment is just like, I want to be using BusyBox, and then it's going to be pulling BusyBox from Docker Hub and running that. You can have the option of like dry run, so it'll tell you information that will happen, but it won't actually run it. And then there's a bunch, you can give it templates, etc. So what I'm just going to do is do something simple, and I am going to create a deployment using Nginx. So just to do that, it'll be kubectl create deployment Nginx, and then image engine is Nginx. The name beforehand is what I just decided to call my deployment. You could call it something else. Some people prefer specifying things like Nginx -deployment, so it's easier to tell versus just Nginx. But for simplicity's sake. All right, so if we do that. Cool. So it says created. That doesn't necessarily mean it is done deploying, but Nginx is really fast. So to actually see what has been deployed, we can do kubectl get deploy or deployment Nginx. So as I mentioned, it's another one of those places where you can have a shorter version or a longer version of the command that you actually need. Cool. So you can see that it has just has one ready and up to date. It can tell you how old it is. So this tells you a little bit of information. There's some other things that you can do. So you can do kubectl get deploy Nginx, and then you can give it an output type. So one of the things is wide, and this will basically, it just shows you a bunch more information. There's what containers there are, what images, and then there's this thing called app selector. And I can show you what that looks like, because we can actually look at what the YAML is that was created with this. So if we go and just do, actually, I'll do that. Yeah, I'll do that now and I'll do it later too. But if we do kubectl git deploy nginx, and then you can either do, you can do YAML, you can do JSON, etc. So basically this is like a ton of the information that you have for what is being run. So you can see there, each object type has a specific API version, and I'll show you how you can actually tell where these fall. So like deployments end up falling in extensions. And so under it, you can then see what kind it is. Then there's specific metadata. So you have different annotations. You can have, there are ones that are added by default by Kubernetes, and you can add your own specific annotations. There's also labels. So this is giving it the label that the app is Nginx. This label can be used for things like when you're trying to create a service and determining what pod or what's running that you're trying to connect to. And then you can see that the namespace is just like the default namespace. And then there's this section spec. So the spec basically is like the meat of what's happening here. If you create your own YAML, which I'll show you what one looks like for doing Nginx after this, you don't have to set all of these things yourself. Some of them are set by default. When you run deployments this way, it will just create a single replica, but you can scale that up, which is what I will be doing next. And a big reason to scale up is, say, so I have 3 nodes, and I have say it's super important that I need Nginx to be running. And right now I only have 1. If that either, say, if that Nginx pod fails, there's the time that it takes to restart. So my app just went, so Nginx just went down. There is, oh no, my node, it just went down. So then I definitely don't have an Nginx running. So there's like a few things. There's the running multiple replicas of your application. And then there's also the concept of running a highly available, like running your worker nodes in a highly available way. So say like there's specific regions. So mine, it was showing the US West one, I believe it was AWS and Google have it swapped for 1 and 2 for California and Oregon. But basically, you have availability zones within that, which are separate data centers. So you could make sure that in your region, you are running each of your nodes across a different availability zone. So in the case of an entire data center going down, your applications don't just die. And then there's like concepts of like how to deal with updates. There's rolling update. You can basically, in general, for how these things are set up, like if you can make a change and it will start, depending on how you have it, it could either create a new pod and wait for that one to finish, then kill off the other one. You could kill off the other one and then start a new one, etc. And then if we dive into this part, this is like the tiny little part here is what you might be used to when just dealing with Docker. So you have your containers, and basically this is just like the image that was put. You have the so there's an image pull policy. So basically it's like, do I want to deal with, if I have it in cache, will I use that, or should I pull it again? So like sometimes where you might want to pull it again is if you just decided I want to use latest. Well, if you pulled latest on your machine may not exactly be the same as the latest that is up on the internet or something like that. Then there's things like the restart policy, like determining, since I mentioned earlier with the pods, if it dies, it won't restart. So here there's certain things that you can choose, like there's always so it restarts no matter what. You can restart based on failure, etc. And then this ends up just telling like things like what is the status, what's kind of like what's happening here. Okay, So now that we have that one pod that we have running, the next thing that we could go and do is then we can actually go and scale it. So if I do a kubectl scale deploy nginx and then give it 3 for my replicas. So if I do that, okay, so now I can actually do a kubectl get deploy nginx and -w, which does watch, and it's actually already up to date. So if you had an app that was a lot slower than this, you would basically see it alternate it going through as each one ends up being ready. And then if we take a look now if we go back and do kubectl get deploy nginx and then give it the YAML again, if we look here, you can now see at the bottom that the ready replicas and updated replicas, etc., is now 3. And you can see when things were updated pretty much, and that there was a new replica set available. Another way to look at your resources, whether it's deployments or anything else, is you can use kubectl describe. So I can do a kubectl describe deploy nginx. And this will tell me some of the like basic information. So like the number of replicas, what my selector and my annotations, labels are, what namespace. You can see things that could like whether like kubelet had some issues, and then you can see kind of what events are happening. And these are both the events for when I first created it, so when I scaled it to 1, and then when it scaled it up to 3. And if something had gone wrong, you would typically also see that here. Another way you can take a look at them is basically, so if I want to, so now we know we have the deployment, but let's take a look at it if we look at it as the pods. So if I do a kubectl get pods dash, I get pods, then I will, let's see the 3. So you can see that the name is the name of your deployment as a preface, and then it has other specific details for each different one. And you can see that there were the one that started much earlier, and then the other 2 that started to make it be 3. And since I was getting ahead of myself, I realized that I didn't want to show that yet. So the other thing you can do again is like kubectl get pods and then -o wide. And then it kind of goes off the screen, but this will tell you a bunch more stuff. So like you can see what is the IP for the pod. And you can actually, an important thing, depending on whether you're like, which can be pretty useful, if you're trying to do debugging, for instance, is you can see what node is running on. So if only one is not working, and if you have the ability to SSH or use Bastion or something to get into your worker node, you can go and take a look at kubelet logs and do some debugging on the actual node. Okay, so now we have nginx running, but we can't get to it from outside of this cluster. And currently I am running these commands on my machine. So I am not in a node that's in the cluster. And so I just can't touch it. So that's where those services that I mentioned come in handy. So the easiest way that as I mentioned also, like if you want to be able to do a lot more specific details, 2 things, you will probably want to do this as YAML versus just running, giving a few inputs as commands. But in order to like go along with what I did for simplicity of just how to set up the deployment, I'm going to do that the same way via the command line, and only that for creating a service. So with the cluster IP, as mentioned, that can only be seen from within the cluster. And since nginx is a web page, that's not exactly useful. then there's also being able to do node port, and with node port, it could involve having to change some of the settings for what ports are accessible, and I did not do that. So I'm going to be using load balancer, and luckily for me, I am not personally paying for these. So what you do is there's this command called kubectl expose. So if we want to just take a look at it, if we do kubectl expose help, which again, this looks way better if you have it on your screen in normal, smaller font. So basically you can see that let me just actually scroll to see if I can see it at the top. All right. So you can choose to do whether you can do it on individual pods. You can, which will end up still applying if you have a deployment, it'll apply to the deployment, but like you can do it on the specific first pod, or you can set it based on the deployment itself. So basically what you do is kubectl expose, and then you give it whatever object type you have. And then you can set things such as, like, if you wanted to give it a name, you give it the port that you want, and then you also have the target port. So basically, if like this thing kind of tells you here, like that it'll serve on port 80, and that it will end up connecting the containers on port 8000. Okay. So if we go back down to the bottom here, so if we do kubectl expose deploy nginx port 80, and then type load balancer, and it's port 80 since that's what nginx works off on. So if I do that, it will create that. And then I can go and look at services. So I can do kubectl get svc or service, either way, nginx, and then -w for watch. So here you can see that there's nginx, and it's of type load balancer. You can see the cluster IP, and the part that we will need is an external IP, which it takes a little time to create. You can see the port, so there's port 80. And then the thing that I mentioned with that range of like the 30,000 to some other number in the 30,000 range, that is the other port that ends up going to me. So I've noticed that when I have a big screen like this, it changes the time and doesn't show me the IP, so I tend to have to run it again. So if I do kubectl get service nginx, okay, cool. So now I have this. So if I copy that, you can also use curl, but if I go here and I go to that, cool. So now I have nginx. And this obviously could be a different page, something much more exciting. I was going to have a spaceship that was going through the sky, but the one I had was from, it was specific to Amazon ECS. So I figured I'll just do something generic for now, since I no longer work at Amazon. Okay, so we have that part, cool. Now what we can do is, if I don't want these around anymore, I can just easily go and delete them. And after I do that, I will show you what this stuff looks like if you are using an actual YAML file to set this up, which will actually look kind of similar to some of the things that you could see when I did it get and show the YAML. So there's a couple ways to go and delete these resources. The first one is to just go and delete each specific one. So the thing that you don't want to do with a deployment, I mean, you can, it's just a waste of time. You could go and try deleting every single pod, but with the way the deployment's set up, it will just create new pods. So what you're going to want to do is actually delete the deployment itself. So you can do kubectl delete and deploy and then nginx. So basically you give delete and then the object type and then nginx. Cool. And then the next thing I want to do is I want to delete that service, which will also get rid of the load balancer. So if I do kubectl delete service and then Nginx. Okay, so now if I did like, another way to like look at all this stuff is if you do kubectl get all, this will get all the things in my current namespace. And this obviously would have been more exciting to show if I actually had anything else running besides Kubernetes itself, which I can show afterward. But you can also get it to show everything in all of your namespaces. So there is a -- all namespaces, but that I'm not going to do that because it's just going to be a lot of stuff to end up showing. Okay. So I have some files that I already created beforehand. So if we just use cat to take a look. So if we have, actually, I'll try, I learned about bat, which actually has some color formatting. So let's see what happens if I try doing it that way instead. So if it's Nginx, deployment.yaml. Oh, nope. Let's see. Oh yeah, I did something with my alias. It's an alias. All right, let's do cat nginx deployment.yaml instead. All right, so sorry, it's not easier to see, but basically you can see that for this, it's created in apps v1. I'll show you where that's determined, like where that part is determined when looking at the API resources afterward. So this is, if you remember what we were looking at earlier, this is just like a much more condensed one, and this is only the stuff that I specifically care about for creating this deployment. So I have like the name, there's that label that was mentioned, there's the number of replicas. So here's the way that like, if you want to specify exactly how many you want, here's a way that you can do that instead of it just running one and then needing to scale up. And then you have your spec, which again has like, is just the stuff that you normally think of with Docker, like what is the name of my container, or what is my container image, and then what is the port that I care about. And then again, with Nginx, container port is port 80. Okay. So to apply this, there's a different way of doing it. So instead of doing a create, you do kubectl apply, and you can give it a -f for a file. So if I do kubectl apply -f nginx deployment, and then just hit enter, you can see that it ends up it goes and actually is creating that. So if I do kubectl get deploy, you can see that we have 3 nginx, and that has just been up for 10 seconds. So we know for sure that it is not the one that was run earlier. So you can also do the same thing for surfaces, and actually really any other type. So if we take a look at the nginx service, so if I do a cat nginx service.yaml, okay, so this is cute and small. So basically, for this, it's just in like the default API resource. So it's just v1. So it just has the version. So kind is service. The metadata name is just the name for the service. And here, if I didn't put a type, it would default to cluster IP. But I specifically put load balancer, so that knows that it will create a load balancer. And then the TCP, I believe that's by default, so I don't think that actually needed to be there. And then port, then dealing with like the ports of like whether it's the container port or the service port. And then there's the load balancer itself. So if I go and do an apply on that, kubectl apply, and then give it that file. Okay, cool, then it creates that. So then I could now basically look at my service again. So if I do, actually before that, let's just take a look at the pods. So if I do a kubectl get pods, and then I can just do a watch on that. These again, obviously it's fast, already running. And then if I do a kubectl get service, you could, as I did before, like give it the name for Nginx specifically, or just do it in general. Since we are waiting for it to come up, we can do get service Nginx and then just do a watch on it. Oh, actually, it's done now. All right, cool. So we basically did two different ways of accessing like the same type of application. So if I just go to, you can see that the IP is different. So if I go to a new page, cool. So now that's also, we have Nginx up again. If we also just like kind of go back and just take a look at like to see some of these other resource types, if we do kubectl and then I can give it kube system and then get daemon set, you can, it's kind of hard to see what's exactly happening here, but like you can, here you can kind of see that with say fluent D, for instance, that the number, and like Prometheus, that the number of desired and whatnot is matching with the number of nodes. And this is not something that you would specify in it. So like if we did a kubectl kube system get daemon set, and then I copied that. There's a lot of stuff in this one, so maybe it's better if I don't like go into all this, but yeah, basically there's a lot of stuff here for the annotations, but you can see that there's nothing in here that is saying that a certain number of like replicas. So it just knows I'm running this on every single one of the nodes. So another way to go and actually, so now that we have all that stuff running, if I did kubectl get all in my current namespace, you can actually see everything that is currently running. So you can see those 3 pods that were created by that deployment. And then the deployment has the replica set, which is the one that's responsible for ensuring like the number of actual replicas. And again, that was like the whole using a deployment with a replica set is the thing that's used now or suggested to be used instead of the replication controller. And then there's the Kubernetes service, which is always there, don't mess with it. And then the one for Nginx. And so there's like 2 ways that you can go and delete everything that is running. So one is I could do a so I'm just going to delete it the way I did earlier, but in a shorter command, but there's another way you can do it. So like what I'll do for just to show you before I hit enter, but is a kubectl delete, and then you can give it deploy comma service and then Nginx, since they're both the same name. This will be is easy, so it knows that it deletes deployments and services. But a better way of handling this, which I'll just enter for now, but the better way of handling this would have been if I did kubectl delete, and then if you do -f, I could here just go and give it the file that I gave with the kubectl apply, and it will remove everything that was added by that. Like this is especially important. Like right now, these are small applications and there's not much, there's just a single little deployment, a single service, and it doesn't really, it's not a big deal. But if you have a giant set of like service accounts with your role bindings and cluster, like all those permissions and everything like that, and say if you have a really long file or multiple files, going through and manually deleting each thing is not the best way to go. So you can just go and apply delete with that exact file and it will delete everything that it created. And since I already deleted it, we don't really need to do it that way. Okay, so, and then what I was mentioning earlier about there's API resources. So basically, if I do a kubectl and then it's just API-resources, and then this, basically it shows you every, like, so if we look here, again, like deployments. Actually, if I start at the top, it might, yeah. So name, short names, what the API group is. So like with the services earlier, it was only showing the version because the API group is just, it's blank. And then it tells you whether it's namespace and what kind it is. So like this, if you're not sure like what all is out there, this is a good way to end up doing that. And if you're trying to write your YAML and you're like, I don't like, I personally don't remember every single field that is needed in my YAML. So I was wondering, is there something that does this, shows me this kind of template for me? And there is. So if you do, I believe it's kubectl explain, and then if I give it deployment, so you can, here is just a high level of everything. And you can kind of just, it gives you links to all these things. But if you just kind of want to see what it is otherwise, if I do kubectl explain deployment, and then I think recursive, it goes through and you can see basically this is everything that would go, you don't need all of this. This unfortunately doesn't tell you, I don't believe it tells you what things are defaulted, but this kind of gives you an idea of what you need and the different types that are required. So if we go back over here, so I only covered so much. It would probably like my friend Jerome Pedersoni does multi-day, like 8-hour workshops and still doesn't get to cover everything. There's just a lot. But some of the important other things to look into are, there's config maps, there's volumes. You just kind of thinking about like how you're dealing with volumes with Docker. So say if you have a database and you want to ensure that everything that you have gets stored somewhere. There's dealing with auto scaling. There's what I just barely brushed over of role-based access control, which is super important for determining like who gets what access, because if you're playing around by yourself, it probably doesn't matter too much. But if you are dealing with production, if you're dealing with people that are just supposed to help fix certain parts of your cluster, or people are just supposed to look at it, or you want to show your friend something, but you don't want them to delete everything you have before your demo the next day. That's where things like role-based access control comes into handy. And you can give specific permissions, like, can they do delete on a pod? Can they read it? Is it only in a specific namespace that there's access? And then these permissions are can also be used for, like, say, if you are interfacing with an external service, and whether it, like, or say I have this, something that I dealt with, like I was writing a Go application and I was using client Go to talk to the Kubernetes API. I had to make sure that my application and what was running in it had permissions to do things like looking at what nodes are, I mean, what pods or nodes or whatever are running. And then there's secrets management, because, well, it's just like you don't want to type your password and have everyone see it. So, and obviously there's more stuff than that. If you look at the Kubernetes docs, it kind of breaks things down. So I was using kubectl for all this. There's actually a lot, there's a whole like web page that I need to find that has tons of tools. But like some of the things you can do, like at the highest, like the basic level is like, so usually people they start with kubectl, like run, curate, expose, etc. And then after that is like when you move to the like fancier or more complicated, the YAML manifest that I was showing. So those are a little more complex, but like you can put those under source control, and maybe you can do things like put in a Git repo, and when you need to deploy something, you just add it to the YAML, you commit a change and deploy a new YAML. So that way you can basically have like a full history of the actions of what you did on the cluster. So this workflow is sometimes called like GitOps. And if you've heard of like infrastructure as code, it might be familiar then. So at some point, like it was realized that maybe we needed to specialize YAML to like maybe defer between like dev and prod. So that's where tools like Customize and it came in. So Customize basically lets you add like patches and overlays to alter your YAML. And then there's Helm, which basically is like the packet. It's a Kubernetes package manager, and it lets you use a templating language, and everything there is basically in YAML. There is a learning curve, like with all of this. The more tools you add, the more you have to figure out how they all work individually and how they work together. But once you understand them, a lot of them can help make your applications run a lot more smoothly and make just life easier. There's also K14S, which is Kubernetes toolings, and the 14 is like the letters between. So this has like 5 or something. There's a certain number of tools there. So there's things like CAP, and CAP is kind of like a fancy version of like kubectl apply, except for you can see a diff before you actually run things, and there's just a bunch of other things you can do with it, and like being able to like just check something, like it will wait until everything is done like deploying and running before it exits out, as you could see earlier. Actually, I don't know if you could, but yeah, you can see earlier for like creating the service, it created it and said it just like exited it out. It wasn't still like running, and then you went and looked and it was not up yet. So there's also YTT, which is another tool that is for YAML templating that like focuses on the like template style itself versus the actual text in it. If like, sorry, there we go. So here are a bunch of, there's a lot more, but here's a bunch of like links and resources. So there's obviously Kubernetes.io. Since I am at VMware, I included our Tanzu site, which has a bunch of different things that are related to and not specific to Kubernetes. There's like tools that help you run Kubernetes across different clusters, etc. And so Jerome Petazzoni has this awesome set of training classes that he does, and you can find a bunch of his slides and some videos that goes into a lot of the stuff I mentioned, but way more in depth, and he's just better at it than me. So if you just go to container.training, and then to actually like interact with people, especially since a lot of things are online right now, meetups, like there's this one, which is great. And then there's things like Slack and Google Groups. If you go to kubernetes.io/community, you can see how to get involved in some of these. There are also a bunch of different free training things out there, and obviously paid ones as well. Some of the free ones is, so VMware, we have Cube Academy, which has like anywhere between, there's a lot of beginner stuff, there's some intermediate, and then I think there's a little bit of advanced, but it's there's continually more content on there. Kubernetes, its own site, has a tutorial doc, and the nice thing with that is you don't have to create your own Kubernetes cluster. It will create a mini kube cluster for you, and it uses Katacoda, and you can just like run stuff there. And then one of the, or I don't remember if it's one or two, but like so the Docker captains, like such as Marcus Nils, had created this thing that was Play with Docker, which would let you just kind of it would spin up a VM and you can play Docker there. There's now one that is for playing with Kubernetes that Docker likes to share out as well. And so thank you for listening and spending your, I guess, lunchtime listening to me talk about Kubernetes. My Twitter handle, which was like on all of the slides, is also here. And I wanted to say special thanks to my friend Jerome, because I've learned a lot of things from him to be able to know what I know now, and continue learning, and have done some workshops with him, and some pieces of the content, a few pieces of the content in here were added based on things I thought that he had done that were great. So thanks. And now I'm going to drink water because I can tell I'm losing my voice.
Thank you, Tiffany. That was really awesome. That was really thorough. I think it was great. Unfortunately we do not have time for a chat. But we do have our Columbia DevOps Slack room, which you can find in the main page. And we're gonna after, I want to make sure that y'all know that we have our charity links, which I'm going to post here. All the slides from everybody will eventually be posted on one of our DevOps pages, so I'll make sure that's taken care of too. But let me see, I had a copy paste.